Hello everyone, welcome back. So today we're going to start a playlist on compiler design unit 1, and I'm going to help you how this is going to exactly help you in this. First we're going to start with lexical analysis. Now as you all know how compiler works, to turn your high level programming code into a machine readable instructions. Understand this, it will give you a solid foundation in programming. Okay, now first let's discuss what is a compiler design. Compiler design is nothing but it is basically a program which translates your high level program into a machine codes, okay, where your computer's hardware can understand and this process involves several stages, now each playing a crucial role in transforming and optimizing this code. All right, so the first one is nothing but lexical analysis, as you can see over here. Okay, lexical analysis is nothing but, now this helps in breaking down the source code into smaller units of code, units like tokens. Okay, like example, your keywords, your operators and identifiers. I'll write it over here: keywords, identifiers and operators. Okay, we can take example like, now let's take it an example. Okay, int x is equals to 10. Okay, now this, after taking it into tokens, how will it come? It will come into int, it will come into single quotes, s x is equals to in one quotation, and then comma in one quotation, and then 10 in one quotation, and semicolon and one quotation. Clear with this? This is nothing but lexical analysis. It helps in breaking down the source code into smaller unit of tokens. Okay, next is the syntax analysis. Now syntax analysis is also called as parsing. What does it do? This basically checks the token sequence against the programming languages using some kind of a grammar rules. Okay, for example, it ensures that the tokens, that is int, let's take this only as example, int x is equals to 10, where this will help us to follow some kind of correct syntax for variable declaration. Okay, now next comes our semantic analysis. Here, what a semantic analysis is, basically this ensures that the meaning of the code is valid. Okay, if you basically it checks before you're sending it to the machine. Okay, it checks if the variables are declared before use, or if the operation makes sense or anything like that. Example, dividing by 0. Now we know dividing by 0 will give us nothing, but then so that is why it checks whether is it having any value or is it valid or not, or else it removes it. And then the fourth one is intermediate code generator. Now intermediate code generator, this basically helps in translating the high level code into an intermediate representation between the source code and the machine code. So this is the source code and this is the machine code. It helps in translating these two. Now for example, transform looks like this. Okay, x is equals to a plus b. Okay, now if you convert this into, this is in a high level code, and if you convert this into a low level version, it might look like this: t1 is equals to a plus b, which means your x will become t1 and a plus b will be the same. Now next comes our optimization. Optimization is nothing but basically it improves the code for better performance by reducing some time or space complexity. Okay, or maybe it for example, it removes redundant calculations or reusing variables to save memory. Using same kind of variables will increase the memory, and to save it removes that redundant calculations. Okay, and the last one is code generation. Now code generation, it helps in converting the immediate representation into actual machine code. For example, we took this as example. Okay, t1 is equals to a plus b. So what does it do? It accessibly, it is an assembly code. Okay, this converts into a binary instruction, so that it is it runs in a faster execution. So for that reason we use this. So if you have to conclude, the compiler designer is nothing but the process of compiling a program into multiple steps, from analyzing the code to generating optimization machine instructions. Each stage is ensuring that your code runs smoothly and efficiently on the computer. Thank you for watching.